Imagine if someone told you that sunlight is simply nature's way of giving your body vitamin D. It sounds reasonable because that's what most of us have heard for years. But this idea is a bit like saying the internet exists only to send emails. While technically true, it barely scratches the surface of what it's actually doing. Your body doesn't experience sunlight as a vitamin factory. It experiences sunlight as information. Every morning, millions of tiny sensors throughout your body wait for one specific signal. Not a pill, not a meal, not a cup of coffee. They wait for light. The moment natural sunlight reaches your eyes and skin, an incredible chain reaction begins. Your brain starts adjusting hormone levels. Your internal clock checks whether it's morning or evening. Cells begin preparing for the day's demands. Energy production shifts gears. It's less like charging a battery and more like turning on the operating system of a computer. Think about how an orchestra performs. Even if every musician has a perfect instrument, beautiful sheet music, and years of training, the performance falls apart without a conductor. Each musician might play well individually, but without someone keeping everyone in sync, the music becomes chaos. Your body works in a similar way. Vitamins, minerals, proteins, and healthy fats are like the musicians. They all have important jobs, but sunlight acts more like the conductor, helping different biological systems work together at the right time. This is why taking a handful of supplements cannot fully replace spending time under natural daylight. Vitamins provide raw materials, but sunlight provides timing. And in biology, timing can be just as important as the materials themselves. Scientists have discovered that many tissues throughout the body respond directly or indirectly to light. The brain, immune system, skin, hormones, metabolism, and even the tiny energy-producing structures inside your cells all change their behavior depending on the signals they receive from the natural day-night cycle. Your body has evolved under this rhythm for hundreds of thousands of years. Every sunrise and every sunset became part of the instruction manual written into human biology. Now consider what modern life looks like. Many people wake up in a dim bedroom, drive to work before seeing much daylight, spend 8 or more hours under artificial lighting, then return home after sunset. On weekends, free time often happens indoors as well. The body receives food regularly, but the light signals it evolved to expect arrive weakly, inconsistently, or not at all. This doesn't necessarily cause immediate illness. Instead, it's more like trying to run an incredibly advanced machine while ignoring many of its instruction signals. The machine may continue operating, but not as efficiently as it was designed to. This is why researchers increasingly view sunlight as more than just a source of vitamin D. It is one of the primary environmental cues that helps organize human biology. It influences when hormones rise and fall, when cells become more active, when repair processes begin, and when the brain shifts between alertness and rest. In other words, sunlight doesn't simply give your body something it needs. It tells your body what to do with everything it already has. And that simple shift in perspective changes the way we think about one of the most familiar parts of everyday life. If sunlight is information, then one of its most important messages is surprisingly simple. This is the beginning of a new day. That single message sets off a chain of events that influences almost everything your body does over the next 24 hours. Hidden deep inside your brain is a tiny group of nerve cells often called your body's master clock. It's no bigger than a grain of rice, yet it coordinates the daily rhythm of countless biological processes. Like the conductor of an orchestra, it keeps different systems working together instead of drifting out of sync. But unlike an ordinary clock, it doesn't tell time by counting seconds. It tells time by detecting light. When morning sunlight enters your eyes, specialized light-sensitive cells send a signal directly to this master clock. Interestingly, these cells are not the ones that help you see colors or shapes. Their primary job is to measure the brightness and timing of daylight. They act more like environmental sensors than cameras, constantly asking one question: what time of day does the outside world say it is? Once the brain receives that answer, it begins issuing instructions throughout the body. Hormones that promote wakefulness start to rise. The production of melatonin, the hormone associated with sleep, is reduced. Body temperature gradually increases. Heart rate and blood pressure adjust to prepare you for movement. Digestion becomes more active. Even your liver starts organizing how it handles nutrients for the day ahead. This is why people often feel naturally more alert after spending time outside in the morning, even if they haven't had coffee yet. The body isn't responding simply because the air feels fresh. It's responding because its internal clock has received a clear signal that daytime has officially begun. Now imagine that signal never arrives. Suppose you wake up in a dark room, spend the morning under dim indoor lighting, and don't step outside until late afternoon. Your master clock receives only a weak version of the message it evolved to expect. It can still function, but its timing becomes less precise. It's a bit like trying to conduct an orchestra while hearing only half the instruments. The music continues, but small mistakes begin to accumulate. Those small timing errors can ripple through the body in surprising ways. Sleep may become lighter or less refreshing. Hunger can appear at unusual times. Energy may rise and fall unpredictably. Concentration may become harder to maintain. Even physical performance often follows daily rhythms, meaning that disrupted timing can affect how efficiently muscles and metabolism work. Researchers have found that nearly every organ has its own internal clock. The heart, lungs, liver, kidneys, pancreas, muscles, and even many individual cells keep track of time. But these local clocks depend on the master clock in the brain to stay synchronized. Morning sunlight acts like the daily reset button, helping them all agree on the same schedule. Think of it like a city where every clock is supposed to show the same time. If each clock begins drifting independently, buses arrive late, stores open at different hours, and appointments become confusing. Nothing is completely broken, but everything becomes less efficient. Morning sunlight helps prevent that drift by synchronizing the body's internal clocks with the predictable rhythm of the rising sun. This relationship explains why sunlight influences so much more than sleep. It affects mood, learning, memory, immune activity, metabolism, hormone release, and even how efficiently cells repair themselves over the course of the day. These systems may seem unrelated, but they all depend on accurate biological timing. So when you step outside into the morning light, you're doing far more than brightening your surroundings. You're giving your body's master clock the clear signal it has relied on for thousands of generations, a signal that quietly coordinates countless processes, helping every part of you work together in harmony from sunrise to sunset. When most people think about sunlight, they imagine it as a single thing, one beam of white light shining down from the sky. But what looks simple to our eyes is actually a remarkable mixture of many different wavelengths, each carrying different amounts of energy and interacting with the body in unique ways. In many respects, sunlight is less like a single medicine and more like an entire toolkit, with each part serving a different purpose. You can see a small part of this diversity whenever a rainbow appears after a storm. The white light from the sun separates into different colors, revealing that it was never truly one color to begin with. Yet even the rainbow tells only part of the story. Beyond the red and violet edges are forms of light that our eyes cannot detect, but our bodies can still respond to. Take blue light, for example. It often gets a bad reputation because of discussions about phones and computer screens at night. But blue light itself isn't the villain. In fact, blue wavelengths from the morning sun are among the most important signals your brain receives. They help tell your master clock that the day has begun, increasing alertness, sharpening attention, and helping regulate the hormones that guide your sleep-wake cycle. The problem isn't blue light itself, it's receiving large amounts of it at the wrong time, especially after sunset, when your body expects darkness. Then there's red light and near-infrared light, wavelengths that make up a significant portion of natural sunlight. Unlike blue light, these wavelengths penetrate deeper into the body's tissues. Researchers have been exploring how they interact with mitochondria, the tiny structures inside cells responsible for producing energy. Some studies suggest that these wavelengths may help mitochondria function more efficiently by supporting the molecules involved in cellular energy production. While research is still developing, this area has generated growing interest because healthy mitochondria are essential for muscles, the brain, the heart, and nearly every organ in the body. Ultraviolet light is perhaps the most misunderstood part of the spectrum. Because excessive ultraviolet exposure can damage skin and increase the risk of skin cancer, it's often viewed as something to avoid entirely. But biology is rarely that simple. In moderate amounts, ultraviolet B light enables the skin to produce vitamin D, while ultraviolet A light may trigger the release of compounds such as nitric oxide, which can help relax blood vessels and influence circulation. Like many natural forces, ultraviolet light offers potential benefits and potential risks, depending on the dose and circumstances. What's fascinating is that your body doesn't respond to these wavelengths in isolation. During a normal day outdoors, you're exposed to an ever-changing blend of colors and invisible wavelengths as the sun moves across the sky. The light at sunrise differs from midday light, and the light before sunset differs again. Over millions of years, human biology evolved alongside these predictable changes, learning to interpret them as signals about time, season, and environment. Artificial lighting, while incredibly useful, often lacks this complexity. Many indoor lights provide enough illumination to help us see clearly, but they don't fully recreate the rich spectrum or the natural progression of daylight. Sitting beneath bright office lights all day is not exactly the same as spending time outdoors beneath the open sky, even if both environments appear equally bright to our eyes. This helps explain why sunlight cannot be reduced to a single nutrient or a single biological effect. It is a sophisticated package of signals with different wavelengths communicating different kinds of information to different parts of the body. Instead of acting like one switch that turns everything on, sunlight resembles an entire control panel, where each wavelength adjusts a different setting. Together, they help guide the rhythms, energy, and functions that keep the human body operating as a coordinated whole. For nearly all of human history, life unfolded under the open sky. People woke with the rising sun, worked outdoors for much of the day, and rested after darkness fell. The cycle of light and dark wasn't something our ancestors thought about. It was simply the environment in which the human body evolved. Every organ, every hormone, and every biological rhythm adapted to this predictable pattern over thousands of generations. Then, in just a tiny fraction of human history, everything changed. Today, many people spend close to 90% of their time indoors. A typical day might begin in a bedroom with blackout curtains, continue in a car, move into an office illuminated by artificial lights, and end in a living room glowing with televisions, tablets, and smartphones. From the perspective of modern convenience, this is perfectly normal. But from the perspective of human biology, it's an entirely new environment. Imagine caring for a houseplant. You give it exactly the right amount of water. The soil contains all the nutrients it needs. The temperature is comfortable and pests are kept away. Yet you place the plant in a dark closet where almost no natural light reaches it. For a while it survives, it may even appear healthy. But gradually growth slows, leaves lose their vibrant color, and the plant begins to struggle, not because it lacks nutrients, but because it lacks one of the most fundamental ingredients of its environment. The human body is far more complex than a plant, but the principle is surprisingly similar. Food provides fuel and building materials. Vitamins and minerals support countless chemical reactions. Yet natural daylight provides information that helps your body decide how and when to use those resources. When that information becomes weak or inconsistent, biological systems don't necessarily stop working, they simply become less coordinated. One of the first systems affected is your daily rhythm. Indoor lighting is usually much dimmer than natural daylight, even if it feels bright. On a sunny day, outdoor light can be dozens of times brighter than the lighting found in most homes or offices. To your brain, that difference matters. Without a strong daytime light signal, the distinction between day and night becomes blurred, making it harder for your internal clock to maintain a clear schedule. At the same time, modern life often delivers the opposite problem after sunset. Instead of darkness, we surround ourselves with bright screens and artificial lighting that extend the feeling of daytime late into the evening. In effect, many people experience dim days and bright nights, the exact opposite of the environment in which human biology evolved. This mismatch can quietly influence many aspects of daily life. People may notice that they wake feeling unrefreshed despite spending enough hours in bed. Energy levels fluctuate unexpectedly. Concentration fades during the afternoon. Mood becomes more variable. Exercise feels harder than it should. None of these experiences automatically point to a lack of sunlight, because many factors can contribute to them. But researchers increasingly recognize that insufficient exposure to natural daylight may be one important piece of the puzzle. This is why the idea of hidden starvation is so compelling. It doesn't refer to a lack of calories or even a deficiency of vitamins. Instead, it describes the possibility that the body is missing something less obvious, the environmental signals it evolved to depend upon. You can eat nutritious meals, stay hydrated, and take carefully chosen supplements, yet still spend nearly every waking hour disconnected from the natural light that has shaped human physiology since long before civilization existed. The solution isn't to abandon modern life or spend every day outdoors. Artificial lighting, climate-controlled buildings, and digital technology have brought extraordinary benefits. The goal is simply to recognize that these conveniences have also changed one of the oldest relationships in human history, the relationship between our bodies and the sun. Understanding that relationship reminds us of an important truth. Health isn't determined only by what we put into our bodies. It is also influenced by the signals our bodies receive from the world around us. And among those signals, natural daylight remains one of the oldest, most powerful, and most easily overlooked. At this point, it might seem like the obvious conclusion is that more sunlight is always better. If sunlight helps regulate your internal clock, supports vitamin D production, and provides important biological signals, then why not spend as many hours as possible under the sun? Because biology rarely works in extremes. Think about water. Every cell in your body depends on it. Without enough water, dehydration becomes dangerous. But drinking excessive amounts in a short period can also be harmful. The same substance that sustains life can become a problem when the balance is lost. Sunlight follows a similar principle. Your body benefits from it, but the goal is not endless exposure. The goal is appropriate exposure. Your skin is constantly balancing two realities. On one hand, moderate sunlight triggers useful biological processes, including the production of vitamin D and other light-driven responses throughout the body. On the other hand, too much ultraviolet radiation can damage DNA and skin cells. Normally, your body repairs much of this damage, but repeated or excessive exposure increases the risk that some damage will remain, contributing to premature skin aging and increasing the likelihood of skin cancer over time. This is why the question isn't simply, should I get more sunlight? A better question is, how can I work with the way my body evolved to use sunlight safely? Timing is one of the most important pieces of the puzzle. Morning light plays a unique role because it delivers a strong signal to your brain without exposing the skin to the most intense ultraviolet radiation of the day in many locations. Just a relatively short period outdoors after sunrise can help reinforce your body's daily rhythm, supporting alertness during the day and healthier sleep later at night. As the sun climbs higher, ultraviolet intensity generally increases. At that point, the appropriate amount of exposure depends on many factors: skin tone, age, geographic location, season, altitude, cloud cover, and even reflective surfaces like snow or water can all influence how much ultraviolet radiation reaches your skin. Someone living near the equator receives a very different level of exposure than someone living much farther north or south, even on the same date. Skin pigmentation also plays an important role. Melanin, the pigment that gives skin its color, acts as a natural filter against ultraviolet radiation. People with darker skin generally have greater natural protection from sunburn, while people with lighter skin tend to burn more quickly. This does not mean one group needs sunlight and another does not. It simply means that the amount of time needed to receive beneficial exposure without excessive damage may differ from person to person. Protection is equally important. Seeking shade during periods of intense sunlight, wearing protective clothing, sunglasses designed to block harmful ultraviolet rays, and using sunscreen when prolonged exposure is expected are all practical ways to reduce the risks associated with excessive ultraviolet radiation. These measures are not signs that sunlight is unhealthy. Rather, they acknowledge that even beneficial natural forces can become harmful when the dose exceeds what the body can safely handle. Perhaps the biggest lesson is that sunlight should not be viewed as either a miracle cure or an enemy. For many years, public conversations have often swung between those two extremes. Some people treat sunlight as something to avoid at all costs, while others describe it as the solution to nearly every health problem. The evidence supports neither view. Instead, sunlight is best understood as a natural environmental signal that the human body has adapted to over countless generations. Like nutritious food, regular physical activity, and adequate sleep, it works best as part of a balanced lifestyle rather than in isolation. No single habit can replace all the others, and no single habit guarantees perfect health. In the end, your body isn't asking for unlimited sunshine. It's asking for the right light, at the right time, in the right amount. That balance allows you to gain the benefits of one of nature's oldest biological signals while respecting the limits that evolution built into the remarkable system you carry with you every day.